This can break the GenAI industry, but no one is talking about it. We all know how LLMs such as ChatGPT has taken the world by storm. These advanced AI systems can generate human-like text on virtually any topic. But with their incredible capabilities comes serious risks if they fall into the wrong hands or aren't implemented properly. And if this happens, customers of your business will lose faith in your application. We are going to dive into 5 critical safeguards that need to be in place to secure LLMs and prevent misuse from data poisoning attacks to prompt vulnerabilities. 2024 is shaping up to be the year LLMs go fully mainstream, so getting security measures right is absolutely vital. Stay till the end to get the most common attack that will be done on your GenAI application. Hi, my name is Joydeep. I have 13 plus years of experience and working as a senior machine learning engineer in the R&D division of a large company. In this channel, I talk about Gen AI carriers and the industry. Now, before we go, here is a small note. Have you been contemplating seeking out career coaching to help you make important decisions about your professional future? Reach out to me here at topmate.io, Joydeep Bhattacharjee, and bring massive success to your career. Link is in the description. So first, your competitors might just try to steal your model weights and predictions to bypass these costs. Training, deploying, and maintaining LLMs are very expensive. One way to mitigate this risk is to watermark your output. One simple way to watermark text is to have a word letter occur at specific intervals in the text to signal that it is machine generated. But this can lower the quality of the text that is getting generated. Um, so going through this paper, this is a very interesting paper. So there are two ways in which you can do watermarking of text. The problem with separating human written and machine written text can be approached from several directions. Broadly, we can distinguish post hoc detection systems that require no interaction during text generation and proactive detection systems that require some action during generation. These later systems are generally much more robust, with the downside that they have to be adopted by the model owner. So the method described in this paper is more of a proactive detection system. So the watermark can be detected by 4 parameters. There is a hash used to detect the green list. So basically what happens here is this is basically a soft approach where a subset of tokens are marked as green tokens. These green tokens will have a small bias associated with it and have a higher chance to get generated. To check if target text is LLM generated or not, the green list is recomputed at each position and finding the set of green list token positions. The statistical significance of a subsequence of tokens is established by deriving the z-score. When the z-score is large, this means that the text is watermarked. So this is the formula for the z-score. So we'll go through the code. This is a collab notebook where I downloaded a Mistral 7 billion model. The watermark detector class and the watermarking config is already there in the transformers, which is based on the implementation as mentioned in the paper. So here we generate the model output using the watermarking config, and we have a detector as well. So once that is done, we do the predictions and you can see the output is true. But if the model is generated without the watermarking, then the prediction comes out as false. Next, I want to tell you about glitch tokens in LLMs. Glitch tokens are tokens in the prompt which result in output that is glitchy and incoherent. It may not be able to answer or hallucinate completely. Here is an interesting video from computer file regarding this. As per research around, so I went through various papers, and as per research, Around 2% of the tokens in the tokenizer are glitchy tokens. So an example of glitchy token is this as shown in the paper. So here in the normal scene, what do we know about the night room? So it gives an answer which is somewhat you can consider it to be somewhat valid, but if you remove the space between the and night room, it goes to a totally different tangent and is not related at all to the question. So these glitchy tokens can result in unknown behavior, and thus becomes important to identify these tokens and stop user inputs, or rather stop generating where user inputs might have these tokens. I experimented using the Gamma 2 billion model, and I tried using this amazing Magic App tool created by Cohere AI. The report, so how to use it is written here. Um, So you can run verification.sh and then run generate results.py, and your results will be created for the specific model. So I'll type in a query here. Write 5 instances of the word Moldura. So Moldura is a glitchy token. Let's see what answers it, what the response it generates. The artist carefully plays intricate details, the fabric of, so as you can see, the LLM is totally hallucinating. Let's try another query. Write 5 instances of the word LLM. So this is another example of hallucination where the LLM is totally rejecting the query that is being passed to it. But if I write something like 5 instances of please, it should work. So as you can see, it is writing 5 instances of please. So this is a valid answer. To run the LLMs in local, when working on the research for this video, I had to work on various LLMs and sometimes keep it running for long periods of time. One way to solve this is download and run LLMs in your local environment. I have made a video showcasing that, and you will find the link above. Next, we'll talk about data and model poisoning. Data is the soul of the model, hence, bad data would compromise the integrity of the model. Famous example is Tay. Microsoft released a chatbot called Tay, which could learn directly from user conversations. Within 24 hours, the chatbot started making racist and inflammatory language, and Microsoft had to bring down the chatbot along with a public apology. For training data, we generally depend a lot on public datasets. A lot of public datasets have wrong labels. For example, 30% of Google's Reddit emotions dataset is mislabeled. Even in a trained model, you don't need a lot of data to poison the model. With only 0.5% of poison data, model performance reduces by 40%. There are three prevention strategies that can be found. Strict validation of input data should be done. We should manually check the data as much as possible. ADA and anomaly detection mechanisms can be found to find adversarial data. Model cards and extensive documentation should be done so that it is easy to debug the model in case of failures. Retrieval augmented generation and other techniques can be used to make the model more robust. Next important item in the list is output validation of LLMs. This can be best explained via an example. Let's say you're running a reporting application which does text to SQL, and then the SQL is directly run on the database. In the general case, a bad SQL may get generated which raises an error resulting in loss of service. In a more severe scenario, a malicious user may delete the full database or gain access to restricted information. To fix this issue, there are packages that perform output validation on the LLM outputs. Generally, you need to provide pedantic schema of the output and then validation is done based on the schema. This may not be sufficient for your use case, but it's a good starting point. There are some nice libraries for output validation which you can take a look, such as guidance, outlines, and instructor. Finally, the most important risk for your LLM applications is prompt injection. Prompt injection is when malicious users use prompt engineering to trick LLMs to give responses that are unintended or malicious or both. It is like convincing the doctor to give you poison. Three ways of prompt injection. Prompted persona switches. Generally, LLMs have a specific persona to make the LLM output better. For example, in the medical domain, the LLM system prompt might be "you're an expert doctor." In this kind of attack, the attacker tries to make the LLM adopt a new persona, something that might be more malicious and provocative. The second way is extracting the prompt template. Here, attacker might try to retrieve the full prompt template. Thus, they can study the prompt template and find ways to further attack the LLM. For example, if the template has some specific tags, then malicious tags might be injected to get the output. Third way of prompt injection is alternating languages or other modalities. An example of this type of attack is when the attacker writes the attack prompt in a different language for an LLM that is meant to only process English text, or an attacker generates an adversarial perturbation corresponding to the prompt and blends it into an image or audio recording. An example of this is shown in the image. A nice method to mitigate prompt injection is to train classifiers that will identify prompt injections. You can run these classifiers on the inputs to the LLMs and thus safeguard them. So finally, we are at the end of the video. In this video, we went through 5 ways in which your LLMs might be vulnerable and how to mitigate those risks, from protecting against data poisoning and adversarial prompts to watermarking outputs and having a robust monitoring systems. Implementing these measures is crucial as LLMs become increasingly mainstream in 2024. Please like and subscribe the videos.